Okay, so in this video I'm going to go over graphs of exponential functions, and we're also going to identify these as growth and decay. Something that I want to go over first is what an exponential function is. Now we notice here an exponential function is in the form of f of x equals k times a to the cx, where k, a, and c are all constants. So they're any number that you want. The only variables are x and f of x. In my class, we've already talked about what a graph is. That's a growth graph or a decay graph. And we decided that a growth graph is something that increases and has an increasing slope. So this would be growth. And then something that decreases or has a decreasing slope is decay. That's not always found by looking at C. Sometimes we can see that, that a positive C value will give you a growth and a negative C value will give you decay, but depending on what K is, this can change that, that idea. So be careful. Most of the time when we do applied problems, this K is our initial population. But if we have a negative number here, it doesn't really make sense for modeling and for an application process. But if this is a negative, then that's going to change the way your graph looks, because if you recall translations, a negative in front of anything is going to give you a reflection about the x-axis. So it's going to change what we're doing here. So I've got 4 problems here that I'd like to graph. We'll talk about some of the major things in the graphs and think about how you can graph these without really needing to make a table of values. The other thing is that I want to stress is that as we go along in this video, take some time to pause it, maybe try to graph these on your own, and then replay and see, replay and see if you can get these right on your own. So we'll start here. We'll plug in -1 into our function here. So we'll get 2 times 3 to the -1. Now 3 to the -1 is 1/3, so we're going to get 2 times 1/3, which is 2/3. I want to be really clear here in that you cannot multiply the 2 and the 3 first. This is not 6 to the x. Please don't do that. A lot of students tend to do this mistake, and it really ruins how you're going to be doing this down here when you're plugging in values. So make sure that you do this part first, do the exponent part first, and then multiply. All right, so we're going to do again here. We're going to plug this into the x. 2 times 3 to the 0. 3 to the 0 is 1, so I'm going to be left with 2. 2 times 3 to the 1 is 6. And 2 times 3 squared is going to be 2 times 9, which is 18. Now, if I talk a little fast here, remember that you have the ability to pause this video, so please pause it when you need to. I only have 15 minutes to make a whole video, so we're going to go through really quickly here. We're going to plot these points now. -1, 2/3. So -1, 2/3 looks to be about right here. 0, 2, 1, 6, and, well, 2, 18 is way up here somewhere. I'm not going to be able to reach that on my graph, but we can see that this thing really increases very quickly. So we're going to graph this, and something we know about exponential graphs is that they approach 0 as a horizontal asymptote. So right there is a horizontal asymptote at y equals 0. Okay, so I want to make note of that. We've got a horizontal asymptote. And pretty much every exponential function is going to have a horizontal asymptote somewhere, because we really can't go below this value. There's no value that we put in for x that's going to give us a 0 for this whole thing. So we've got a horizontal asymptote, in this case at y equals 0. Now this may change depending on our function. If we raise this function up or lower it down, then we might have a different asymptote. But for anything we're going to have, for any of these types of functions, we're going to have a horizontal asymptote. Now we cross here at 2, so we're going to have a y-intercept. And this graph, if you notice here, this graph, the slope of a tangent line, remember a tangent line crosses at one point, the slope of this line is going to be positive. In general, this entire thing is increasing. And if it's increasing for all values of x, then we're going to call this a growth function. So this right here, this is growth. And we can see that because it increases. We also see that the power here is positive. There's no negative in here, so we can see that it grows. Okay, so now let's take a look at another example. So then we have y equals 3 to the negative x. Now I want you to remember that this negative is up here in the power. And if we had a function f of x, I just use green, I use blue. If we had a function f of x equals 3 to the x, and we plugged in a negative, f of negative x, then that would be 3 to the negative x, because we just plug in a negative here. If you recall our translations, this right here is a reflection about the y-axis. So what we should see is for f of x equal 3x, which kind of looks, I'm just going to quickly draw something here, kind of looks like that, we should see a reflection about the y-axis, maybe something going this way, at least if it follows our rules of translations. So let's pick some points, -2, -1, 0, and 1, and we're going to figure out what the y value is. Now you can pick anything you want. I pick these because I think they work well. So we're going to plug in -2 is going to give me 3 squared, which is 9. Okay, so we got 9. And then 3 to the -1, which is positive 3. 3 to the 0, which is 1. And 3 to the -1, which is 1/3. So we're going to go over here and graph these. -2, 9, that's something way up here. -1, 3. 0, 1. And 1, 1/3. And, well, will you look at that? We have a graph that if we remember what we had there before, this really does kind of reflect the y-axis. Notice here also that this is a decreasing slope for all values of x. So this would be decay. We can also see that because we have a negative in the power, but no negative in front. Okay, so again, we've got 2 more examples. You can do those on your own if you'd like, and then pause the video and come back and check to see what we got. Okay, our next example. We've got a lot more things going on here, but if we think about this in translations, we're going to shift to the right, no, I'm sorry, to the left 1. We're going to reflect the x-axis, and then we're going to add 3 units. So we're going to go up 3. So if we did this, let's see, we're going like this, and then we're going to shift it over, and then we're going to reflect, so we're going to look down like this, and then we're going to go up 3. So it should look like this, only up here somewhere. Okay, so let's see if that is exactly what we have. So we're going to plug in -2. -2 plus 1 plus 3. And we're going to have -2 to the -1 plus 3, which is -1/2 plus 3, which is 2.5. Now we're going to plug in -1, which is, this is going to be 2 to the 0, so we're going to have -1 plus 3, which is 2. -2 to the 0 plus 1 plus 3 is going to be -2 plus 3, which is positive 1. And -2 to the 1 plus 1 plus 3, which is -4 plus 3, which is -1. So we're going to plot these now. Let's see what we get. -2 and 2.5 is here. -1 and 2. 0, 1. And 1, -1. Well, that really does look like what we thought was going to happen. All right? So here we go, and there you go. There's the function that we thought, and here's what we ended up with. And we end up getting the graph that we wanted. So here, the horizontal asymptote now is at 3, and we got a plus 3 there. So we can see that outside, this is gonna change that horizontal asymptote from 0 to up to 3. Okay, so we got one more to look at. Oh, correct me, I'm wrong. I had 3 of them for you to do. So that's the end. Hopefully you get enough out of that. You can just make up any of these that you want. You can even, if you wanted to just take any exponential, I would say stay within 1s, 2s, 3s, and 4s. You don't want to get any larger than that. Put something in front like a -3. And then a power, a base. Let's say you want 2. You can always do like -x, and then add or subtract something, and see what happens. You'll notice here though that whatever you add or subtract, this is going to tell you what that horizontal asymptote is. So take a look at some graphs and see if those are. If you have a graphing calculator, take a look and see if you can come up with some patterns. And there's some really neat patterns that emerge from graphing exponential graphs. Okay, so that's it for the first part of just looking at exponential graphs. In my next video, I'll go over looking at how do we solve some exponential functions and find this y value. Okay, thanks for stopping by. Good luck.